Welcome to The Explainer. So, today we're going to completely reframe how you look at broken code. Let's be real. For a lot of us, debugging feels like a massive chore, right? A frustrating roadblock that just stops us from building the fun stuff. But we're flipping that script today. We're going to look at debugging not as frantically typing and crossing our fingers, but as a thrilling, scientific investigation. And in today's tech landscape, every good detective has a high-tech assistant, artificial intelligence. But here's the catch. Just like any power tool, if you don't know how to use it, it can absolutely lead you down the wrong path. So let's gear up and master this investigative process together.
Okay, let's take a quick look at our roadmap for today. We'll be covering 5 main areas. First, moving from symptom to cause. Second, using AI as a partner, not an oracle. Third, prioritizing evidence over guesswork. Fourth, security and AI debugging. And finally, building a professional error culture.
All right, let's jump right into Section 1, from symptom to cause. I want you to be totally honest with yourself for a second. When that wall of red text flashes on your screen, what's your immediate reflex? Seriously, do you just copy-paste the whole file and the error straight into an AI chat? Or do you take a beat, read it, and try to actually isolate the error first? Because just taking a breath and making your problem reproducible, that literally changes the entire quality of your troubleshooting.
Now, there's a really crucial distinction we need to make here between a symptom and a cause. The symptom is just what we're observing. It's the crash, it's the wrong output, it's the visible smoke. But the cause? The cause is the actual fire. It's the broken assumption we need to uncover. As programmers, we constantly build mental assumptions, right? Like, oh, this variable is never empty, or this API is always going to return this specific format. Debugging is simply the empirical process of testing those assumptions, one by one.
Moving on to Section 2, AI as a partner, not an oracle.
To put into perspective just how urgent this is, check out this data from the 2025 Stack Overflow Developer Survey. A massive 84% of developers are either using or planning to use AI tools, and 51% of professional devs are using them every single day. So AI is undeniably here. It makes us incredibly productive by explaining error messages or sorting through possible causes. But, and this is a huge but, it can also deliver some incredibly convincing yet entirely false explanations.
And that brings us to this point. It really all boils down to how we talk to our assistant. Look at the amateur prompt. It just begs, fix this code. That basically forces the AI to guess the context and slap on a quick patch, which usually just masks the symptom. Now, look at the professional prompt. It demands, which 3 assumptions should I check? See the difference? This separates the diagnosis phase from the repair phase. You're asking the AI for testable hypotheses, not a magical band-aid.
But listen, before you even interrogate the AI, you have to read the hard evidence found in the stack traces yourself. I know they can look intimidating, but you just need to peel back the layers. First, identify the exact error type. Second, trace it back to find the closest line in your own code, because, let's face it, the error usually isn't in the library code, it's in how you called it. And third, determine exactly what assumption was violated on that specific line. Once you've done that groundwork, then you can feed a highly precise prompt to your AI partner.
Which perfectly transitions us into Section 3, evidence over guesswork. This professional debugging loop you see here mirrors the scientific method almost perfectly. You observe a problem. You formulate a hypothesis, maybe with the help of your AI. But then you absolutely must test it. Tests are how we make the invisible visible. A good unit or integration test takes a vague observation and turns it into a controlled experiment. Only after that test proves your hypothesis do you actually implement the fix, and then, of course, document it.
And don't forget, version control is literally your time machine in this process. Sometimes the evidence we need is historical. Think about regressions, when code that used to work flawlessly just suddenly breaks. Version control lets us track a hidden regression from the exact day it was committed, through the weeks it lay hidden, right up to the moment it triggered a timeout in deployment. Tools like getBisect are amazing for isolating that exact commit. Then, your AI can analyze that specific code diff and tell you exactly what unintended side effects it might have caused. You don't just have to take my word for it. Even the creators of these AI tools are issuing warnings. GitHub Copilot's best practices explicitly remind us that AI suggestions must always be validated by the undeniable truth of automated tests. You just can't accept code because it looks correct on the surface. You have to prove it runs correctly in your specific environment, playing by your specific rules.
Okay, let's talk red tape. Section 4, Security and AI Debugging.
This is your absolute non-negotiable checklist. When you grab a log file or a stack trace and feed it into an LLM, you are risking some massive data leaks. You must actively redact personally identifiable information, customer data, API tokens, passwords, internal architecture paths, and proprietary business logic. Organizations like OWASP are warning heavily about prompt injection and the accidental disclosure of sensitive info, so professional debugging absolutely requires a strict redaction phase before you even think about asking for AI help.
Finally, let's zoom out a bit for Section 5, Professional Error Culture.
The contrast between blame and responsibility is really what defines a professional software team. An amateur team gets bogged down in blame. Who wrote this terrible code, right? But a pro team, they focus on responsibility and blameless postmortems. They ask, what missing automated test, or what gap in our code review process, or what misunderstood AI suggestion actually allowed this error to reach production? This culture allows you to fix the system, not attack the people. Because at the end of the day, when AI suggests code, the responsibility for testing it and understanding it still rests 100% on the human team.
As we wrap up this explainer, I want to leave you with one final, provocative thought to chew on. When you copy an error, paste it into an AI, and then just paste its solution right back into your codebase, are you outsourcing your mastery? Or are you using these incredible tools to deepen your own understanding of the craft? AI can be the absolute greatest tutor you've ever had, but only if you ask the right questions, demand testable hypotheses, and absolutely refuse to commit code that you don't fully comprehend. Keep investigating, keep testing, and I'll catch you in the next explainer.